Form 4 Chapter 3. Now, untuk tahun ini, Form 4 Chapter 3 hanya ada satu state keluar lah. So, it's not a very common topic for actually this year punya SPM. So, I actually got add my own question here as a bonus to revise with you all lah. Right, so first one, the one and only state trial that came out from Chapter 3, Selangor one. So they ask, kena pasti mana adalah pelarut dan zat terlarut. So pelarut always adalah your air. So pelarut adalah bahan yang melarutkan, zat terlarut lah. So your zat terlarut is always like your garam lah, your gula lah. So in this case, your zat terlarut is sucrosa. Alright, this one I think I don't need to explain much lah. Quite simple. Pelarut in bio is mainly water. Water can melarut almost everything in this world. So that's why we call it pelarut semesta universal solvent. And they ask, dalam Raja 1.1, lukiskan anak panah untuk menunjukkan arah pergerakan molekul air yang akan berlaku. So air always mengalir dari larutan hypo ke hipertonik. Hypo, remember, is like hipo. Hipo suka air, so hypo always is more water punya larutan. Air always mengalir dari, meresap dari keupayaan air tinggi ke keupayaan air rendah. So if you have 10% sucrosa, you have 90% air. If you have 30% sucrosa, you have 70% air. Because in my larutan only got two things mah, air and pelarut mah, zat terlarut mah. So if zat terlarut is 10%, pelarut air will be the remaining one, 90%. So more water go to less water. 1.2 menunjukkan keadaan satu sel tumbuhan yang telah direndam di dalam air suling selama 1 jam. So air suling is all the time larutan hypo terhadap semua sel because you have 100% water mah. So obviously water keupayaan tinggi ke rendah, water obviously will masuk the cell because here is paling tinggi already 100%. So your cell you can see kembang already. This is called segah lah. Which then the question say, if now this cell saya rendam dalam larutan garam berpekatan tinggi. So if the garam pekat, the air kurang lah. So now this is definitely hipertonik, which means the water, the air akan keluar. Sebab luar tak ada air mah, pekat mah, ada garam a lot, water low mah. So air akan meresap keluar. So you have to draw a cell untuk menunjukkan keadaan sel ini. Now, for sel tumbuhan, dinding sel tidak akan berubah no matter what. So first draw the dinding, draw 2 rectangle like this. Okay, that is the dinding cell. Now, inside, right, the membrane plasma akan mengecut already. So dia akan menjauhi dinding sel. Your nucleus remain. The vacuum menjadi kecil. So the two main things you kena label is definitely vacuum, because vacuum menjadi kecil, berubah already. And another thing that berubah is your membrane plasma. So this one must label also. Alright, and soalan akhir di sini they ask, berdasarkan jawapan di A1 nyatakan keadaan sel tersebut. So sel tumbuhan mengecut already, we call it as flare seed. If they ask us to terangkan, sini saya bonus you lah terangan. So the terangan here is larutan garam pekat you must say adalah hipertonik terhadap sel tumbuhan. So must compare air, molekul air meresap keluar melalui osmosis. So if it's for this one, then terbalik only lor. Air suling hypo terhadap sel tumbuhan, air meresap keluar ke dalam melalui osmosis. And for the bonus question, here, okay, this one I pilih the pergerakan bahan melintasi membrane plasma question lah. Like molecule apa melintasi which part of the membrane plasma melalui pengangkutan apa. So here we mainly do this one only lah, the protein pembawa one. So protein pembawa ada 2 pengangkutan. So A you can see kepekatan tinggi ke rendah. So saya menuruni keturunan kepekatan. So this one A, okay, they ask you jenis pergerakan. This one definitely is resapan berbantu. So cannot say pengangkutan pasif because passive you have 3 types. So you have pengangkutan pasif. We have what? Osmosis untuk air. We have resapan ringkas untuk gas dan molekul larut lipid. We have also resapan, this one berbantu. Osmosis, osmosis. And resapan ringkas hanya berlaku pada dui lapisan fosfolipid. Berbantu hanya berlaku pada protein, liang and pembawa. So how do I know this is pembawa? Because pembawa is always like this one. And pembawa got like some this lobang here like tapak active like that. Yeah, for liang liang is like got one longgang in the middle one. This called liang. So at protein pembawa, there are two pengangkutan. One is berbantu, one is active. So berbantu right is sejenis passive so it's always kepekatan tinggi ke rendah. So that's why I know this berbantu loh. And then you can see rendah to tinggi. Naik one, rendah to tinggi is pengangkutan active. Pengangkutan active only got one example, so straight pengangkutan active. Then if no question didn't ask this, but let's say if they ask you to nyatakan apakah molecule A dan B. So for resapan berbantu pada protein pembawa right, is only for molecule yang besar. Siapa example molecule besar? Is like your sugar, glucosa, and also acid amino. Then for pengangkutan active right, is definitely only for ion. Bercas. So siapa example bercas? You can say ion natrium. Like your ion garam lah. So in our Form 4 Chapter 3, pengangkutan active right, hanya ada satu contoh, which is ion. And only ion can rendah to tinggi one. Okay, but let's say if ion natrium right, like this, it will then be resapan berbantu and hanya boleh berlaku pada protein liang. So let's say if they show you the same thing lah, protein liang like that, definitely is tinggi to rendah, no active at protein liang one so this thing mesti adalah your ion natrium. Ions, bercas lah. And the pengangkutan right, definitely is resapan berbantu. Again, osmosis and ringkas is definitely only for dui lapisan. So yeah, this one is resapan berbantu loh. Tetapi resapan berbantu pada protein pembawa hanya adalah untuk molekul besar, iaitu glukosa. Because this one besar so besar cannot come in from here one. Here too small, need the lobang. This one the lobang can change. Understand? So itulah jawapan. Then pergerakan molekul B merentasi membran plasma tidak dapat berlaku tanpa kehadiran bahan X. So apakah X? So for active, what you need? You need tenaga lah. So the molecule yang membagi tenaga ialah adenosina triphosphate ATP. You can just write ATP. And the next question adalah tentang this liposom. Okay, if you forget what's liposom, right? Liposom adalah dui lapisan fosfolipid buatan manusia untuk mengandungi obat. Because this is to protect the obat from being destroyed by your jus gester dalam perut. Because jus gester is acid acid akan merosakkan banyak-banyak obat lah. But some obat right, inside got living cell, cell hidup one. Same, they also can protect it. Which this question is now asking. See tanpa liposom, sel-sel hidup dalam liposom ini akan mati dengan lebih. Tengok ada 60% mati. Tetapi if I use liposom, mati punya kurang daripada 20%. Means you still have a lot of living cells inside. So sometimes right, obat inside will have living cells to help your body one. Okay, so the question asks, berdasarkan graf di 4.2, terangkan kesan pengguna liposom dalam sistem penghantaran obat. So you have to say right, this thing melindungi itu sel daripada your juice caster. So since the juice caster doesn't merosakkannya, selepas your perut is your usus kecil. Usus inside will have enzyme seperti lipase untuk mencernakan ini dui lapisan supaya usus boleh menyerap obat-obat or sel-sel inilah. Yeah, so that's why the kesan pengguna liposom adalah lebih berkesan lah. Sebab itu sel tak mati Kenapa sel tak mati? Sebab liposom melindungi sel normal yang sihat daripada dimusnahkan oleh juice caster. Juice caster is your stomach punya acid lah. So normally question will ask right, mengapakah vitamin C, let's say like supplement, vitamin C dikandungi dalam liposom. So same. melindungi itu vitamin C daripada dimusnahkan oleh jus gester supaya menghantar kepada sel badan dengan lebih berkesan. So that's the answer. Last, satu kegunaan lain liposom, terangkan jawapan anda. So satu lagi kegunaan you can say is untuk bahan kosmetik. So other than obat, cosmetic, facial cream, for example. So some facial cream right, inside also got living components, bahan yang hidup. So this thing also to melindungi itu bahan hidup. So now when you use the thing, right, it's like a capsule, you can pop it, then the cream you put on the face. So then you can say, untuk memastikan bahan aktif dalam produk sampai ke lapisan kulit, because this thing can protect the bahan hidup dalam. So once you pop it out, you can straight put in your face and go inside your face. That's how it functions. So that's the thing. Okay, so bug 3 this year not too important lah. So I got one extra question here. Hopefully can help you all. And once again, see you in my next video. Bye bye.